Okay, so today will be our first attempts at graphing quadratic functions all the way in standard form, meaning there's going to be an a, b, and c value. Last week we started with a, we worked c in, now today we're going to get b in the mix. So again, understand a and c are still going to control things that help us out. We should be able to look at the a value and see stretch or shrink, and if it's negative, it's going to do a reflection across the x-axis. The c value is our vertical translation. It's always going to be our y-intercept. That's kind of the more helpful thing for us once we get b incorporated into our functions. So let's just take a look at how we do this. So again, we're graphing in standard form, and then later on we're going to identify minimum and maximum values, but really there's nothing different there, just learning a term. So first things first, when we started graphing these, I said the most important thing that we need to do is understand I cannot start my problem without knowing my axis of symmetry. So as you can see here in the notes, it says the axis of symmetry is equal to negative b over 2a. So whenever I want to find that value, when I have all three terms, I have to plug in negative b over 2a. Now, much like anything else, when we find an x value for our function, which is what the axis of symmetry is, in order to find our output, we simply plug it in. So when I go to find my vertex, I need to evaluate my function at whatever that value was. So if you found that your axis of symmetry, let's say in this is 2, I'm going to plug 2 in, and it's going to find me this point right here. Now the third step, okay, so the third step is the one that kids always kind of struggle with, but if you think about it, it's just plugging in a couple more numbers. We need to decide which ones. So pick 2 and reflect. Now, the 2 depends on where this axis of symmetry is. For instance, like I said, if this axis of symmetry is 2, the next value I could plug in would be either 3 on this side or 1 on this side. Now, I'm going to pick 1 because it's probably going to be easier, and then I'm going to reflect my value to 3. I could also plug in 0, or just know that my c value gives me my y-intercept, and then reflect it to 4. So you don't have to plug in 5 numbers, you need to plug in 3 by the time it's all said and done, and you should have 5 points. So the best way to do it is just by practicing. So we'll work one out here. So first step, axis of symmetry, x is equal to negative b over 2 times a. When I go to plug that in, it's going to be negative 8 over 2 times a is 2, which is negative 8 over 4, which is just negative 2. Now again, write this down on paper. Make sure you guys are writing these problems and working them out. So my axis of symmetry is negative 2, and I'll change my line's color here to red, and I'll make it dotted so that we know that's our axis of symmetry. So negative 2 right there. So it's not very big. Again, it's not actually part of my graph, so I don't need it to be super big. I just need to know where it's at. So now I found my axis of symmetry, x equals negative 2. So in order to find my vertex, I need to plug negative 2 into my function. So I'm going to say my function evaluated at negative 2, and I'm just going to plug it in. 2 times negative 2 squared plus 8 times negative 2 plus 1. So negative 2 squared is 4. 8 and negative 2 is negative 16 plus 1. Hopefully this fits. 8 minus 16 plus 1. So that's going to be 9 minus 16, which is 7. So at 2, I'm already up at 7. Now, the next points probably aren't going to fit super great, but we should be able to tell where they are. Now, when we go to do this, did I have a sign error somewhere? Oh, it should be negative 7. I apologize. So let's undo that point. It should be negative 7. There we go. So 2 comma negative 7. Now, I want to plug in a couple more points. Now, the low-hanging fruit is always your y-intercept. So we're going to put our vertex down, -2, -7. We plotted it. If I look to this value right here, that's always my y-intercept. So I can go plot that right now, and then I can, again, plot its reflection. So if I'm at 0, -1, 1, 2 away, I go 1, 2 the other way, and I plot that point. So I'm also at -4, -1. So 0, -1, and -4, -1 give me a point. Now this is sufficient. If there's only 3 points, that's fine, but we could plug in another point here pretty easily. So if I plug in -1, 2 times -1 squared plus 8 times -1 minus 1. So 2 minus 8 minus 1, 2 minus 9, I get, why did I change that to plus? Did I mess that up in the earlier part? This should have been a minus. This messes my graph up a little bit. 17. This should be a 9. I messed that up a little bit. We're going to fix that. We're okay. Good thing I'm seeing all these mistakes as I record live, huh? Here we go. All right. I did do my math wrong there. Hopefully some of you guys saw that. So this one, if I plug in -1, is going to be my output of -7. That's why I saw something was off. So at -1, I'm here, and my reflection at -3 is also there. Again, I had a sign error up here for some reason. I started writing plus at the very beginning of the problem. These should have been minuses all the way down. But nonetheless, we found our error. We fixed it. There we go. So there's actually what your graph looks like. Now, when we go to do this, now we can discuss the translations and the transformations and all that stuff once the graph is down. I'm probably not going to do this part in standard form, but we can do it for the sake of vertical stretch by 2. Okay, and we technically moved down 1, but not really. So this B really kind of messes up that transformation. And then the other thing I'd probably look for is a vertical reflection. Now, domain and range should be on all of them. Domain is all reals. Range is y is greater than or equal to, and again, I fixed this, -9. Okay, so y is greater than or equal to -9. Now, again, there's lots of practice here, and for the sake of the video not taking up a ton of time, I'll work some out, but make sure you're asking questions in class. But I do want to show you kind of the sliders on Desmos. So here's our parent graph. And what I want to show you is what our parent graph does when we have values change. So we already know that as A gets bigger than 1, it's a stretch. As A gets less than 1, it's a shrink. Okay. We know that as C goes up, it's a vertical translation up and down. Okay. But if I leave my A and C values alone at where they should be, if I can get it to stop on 0 here. Okay, if I leave A and C alone, watch what it does if I just change my B value. So my B value slides it along that y-intercept left and right, but it's kind of opposite of what you think. So as B gets bigger, it's actually shifting it so that the value on your intercept gets bigger, and it's shifting it so that the value on your intercept gets smaller when you shift it left. But it kind of shifts it weird. So we can't always rely on looking at those values to help us find coordinate points. That's why there's that function -b over 2a. So now if I go back to this and I turn on my -b over 2a, that dotted line, as I switch what b is equal to, it's always going to stay right in the middle of my parabola. So that's why it's so important to identify that axis of symmetry. Now, like I said, for the sake of time constraints on the video, I want to make sure we understand how to get these values and stuff. But what I'm probably going to do is go pretty quick on some of these and go through them so that you can see values. But before I work on these, I'm going to go ahead and help you out with the vertex and axis of symmetry and the pick 2 just on a couple of them, and then kind of move on. So on the first one, we're going to do -b over 2a. So we have -2 over 2 times 3. So this is +2 over 6, which is 1/3. Now, I'm not going to do this to you on the test because this is almost impossible to graph. Our axis of symmetry is 1/3. To get my output, I would have to plug that in. So it's 3 times 1/3 squared minus 2 times 1/3, and it just becomes a royal pain in the butt. So this would probably be a good example of one you will not see on your test. Okay. Now, the next one is one that's pretty easy. So if we do negative b, so it's negative 6 over 2 times a is 1, which is negative 6 over 2, which is negative 3. So now I can graph negative 3 pretty easily. Here's my vertical line at negative 3. Then I go to plug that in. So I have negative 3 squared plus 6 times negative 3 plus 5. So negative 3 squared is 9 minus 18 plus 5. Okay, so if I take 9 and 5, that's 14 minus 18, and I get negative 4. So 1, 2, 3, 4, negative 3, negative 4. Now, again, I always am going to look at this term right here because that's going to tell me my y-intercept. So 1, 2, 3, 4, 5. There's my y-intercept. I can count from my vertex 1, 2, 3 units. So I go 1, 2, 3 units, and then I plot that point right there. So 3 units to the left is right here. Select the pen, please. There we go. And then pick another number that's close to negative 3. So if I plug in, for instance, if I plug in like negative 2, so I have negative 2 squared plus 6 times negative 2 plus 5, 4 minus 12 plus 5. 4 plus 5 is 9 minus 12 is negative 3. So at negative 2, I'm at negative 3. So here's my parabola. I have 3 points. Now, what we should notice here is the fact that, one, our A value, there's no stretch or shrink. Okay, again, the translation left and right gets messed up by B, so don't worry about that. My domain is all reals. And then my range is y is greater than or equal to, let's see, 1, 2, 3, 4, negative 4. Okay, so again, we should have a pretty good idea of the rough sketch of our graph. Again, number 3, it's not as bad as it looks, but if you plug it into Desmos, you should be able to check your answer there. All right, so I'm going to go on to example 2 here and describing the domain and the range. So again, we start with the formula x equals negative b over 2a. So we have negative 6 over 2 times 3, which is 6 over 6, which gives me 1. So my axis of symmetry is x equals 1. I go ahead and go graph it over here. And now I have the value 1 that I need to plug in. So 3 times 1 squared minus 6 times 1 plus 5. 1 squared is 1 times 3 is 3 minus 6 plus 5. And I get 8 minus 6 is 1 comma 2 is going to be my value. 1 comma 2. So I go ahead and plot 1 comma 2 on my vertex. Now my next value that I can plug in, again, I don't need to plug in 0. It's right next to it at 0. I'm already up at 5. So 2, 3, 4, 5 right there, and it's reflection. So if I'm at 0 comma 5, the reflection is at 2 comma 5. And then I can plug in negative 1. So let's see what we get up to. 3 times negative 1 squared minus 6 times negative 1 plus 5. 3 plus 6 plus 5. I'm already off my graph. I'm too far up, so it doesn't really matter here. It's a vertical stretch by a factor of 3, so it gets tall fast. Now, again, we've already been doing domain and range. All reals. Okay, and then we have y is greater than or equal to 2. All right. So again, it's just more of the same because I've had you guys describing domain and range the whole time. Example number 2 and those problems should be no different. And we're actually going to do them on paper. So don't worry so much about the big ideas not being there. We're going to have you guys open those up on the book. All right. So again, use Desmos to kind of check yourself on this. You just go in and plug in. So if I do the first one, for example, 2x squared plus 4x plus 1, if I go into Desmos, I can just type that in. So 2x squared, I want to put a 2 there, not a 5. A 2, can I type? 2x squared, and then plus 4x, and then plus 1. So there's what my graph on that practice problem should look like. It gives you your axis of symmetry. Again, if you type it in like this, make sure you ask for help if you can't quite get there. But for the sake of time on the video, like I said, use Desmos to kind of check your graph. Negative b over 2a, and then you plug it in. That's how you get those values every time. Okay, so check Desmos, use those. I'll work out negative b over 2a on these real quick. So negative b over 2a. So my axis of symmetry should be negative 1 on this one. Negative b over 2a. My axis of symmetry should be 4 on this one. Okay, and then you plug it in. This one, negative b over 2a would be 10 over negative 10, which is negative 1 on this one. So they've actually worked out pretty nice for us, those axis of symmetry on this one. And then they have you describe your domain and range once you get more points. Okay, so just as a kind of friendly touch base on this, if my axis of symmetry is negative 1, I'm probably going to plug in 0 and then positive 1. If my axis of symmetry is 4, I'm probably going to plug in 3 and 2, or I have 0, 7 that I can graph. Again, axis of symmetry is negative 1. I'll probably plug in 0 and get negative 2, and then plug in 1 and see what I get. Okay, now minimum and maximum before we're all done. Like I said, I want to keep this video short for you. Minimum and maximum is just referring to the vertex. Okay, that's all it is. So when they ask you whether your function has a minimum or a maximum value, if your function opens down, your vertex is called a maximum. In other words, if your a value is negative, you have a maximum. The way you find it is exactly like what we do up here. So for instance, if I want to find the minimum or maximum, first of all, I look here. It's a min because my function opens up. I find my x value and I plug it in. So 2 comma negative 1, or 2 times negative 1 squared plus 4 times negative 1 plus 1. 2 minus 4 plus 1, and I get negative 1. So my min value is negative 1 comma negative 1. Okay, it's no different than what your vertex is. It's exactly your vertex. It's just you're going to call it a minimum if it opens up and a maximum if it opens down. So here, again, we don't even need to graph. We say, okay, here's our sign. It's opening down. We have a max. And then we plug it into the function. X equals negative 24 over 2 times negative 4. So 24 over negative 8, which is negative 3. And then I plug negative 3 in. So negative 4 times negative 3 squared minus 24 times negative 3 minus 19. Okay, so negative 3 squared is 9 times negative 4 is negative 36. Negative 24 times negative 3 is positive. Oh, let's see, 2, carry the 1, 72 minus 19. So let's punch that in, 36 and 19. So 36 plus 19 equals, and then I'm going to take that away from 72. So it should be positive 17. So at negative 3 comma 17, I have a maximum value. And again, my function will open down because of that. So again, it's the same process. It's the same process as finding your vertex. Okay, so again, don't worry about this one. Check your answers on Desmos. Do your min and max the same as your vertex and axis of symmetry. But I don't want this video to go too long. Again, during your work time and your practice sets, make sure you're working every single thing out on paper. Bring questions to me on your paper and we'll help you out. We're not going to have big ideas for this section, so you're going to have to open up your student dynamic ebook on your Chromebook and work those problems out on paper for me. When it says to graph, When it says to find min and max, don't worry about graphing. Thanks, guys. Have a great day.